Right. Good evening, everyone. Now we are going to start discussing about the alkanes today. So the topic today is alkanes. Right. So this is the first type of organic compounds that we are going to learn under under this organic chemistry. Actually, alkenes and alkynes. There are three different kinds: alkanes, alkenes, as well as alkynes. Right. Along with benzene, these four come under the category of hydrocarbons. Right? So they come under the category of hydrocarbons. So let's see what are hydrocarbons. So hydrocarbons are compounds that contain carbon and hydrogen only. Right? Only. That means these hydrocarbons, they contain carbon and hydrogens only. For example, if we consider alkanes, we call them saturated hydrocarbons. Alkanes are called saturated hydrocarbons. We call them saturated because they have carbon-carbon single bonds. That means we know that each carbon atom can bond with four other atoms or molecules. So it can form four bonds. Now these carbons, they can form only single carbon-carbon bonds. In alkynes, that is alkanes. Then in alkynes, there is a carbon-carbon double bond. Right. So there are four bonds. Out of the four bonds, there's a carbon-carbon double bond in alkenes. In alkynes, there's a carbon-carbon triple bond in between two carbon atoms. Benzene is somewhat different. It is symbolized like this. Right. So let's talk about benzene later. Now I think you got a rough idea about what hydrocarbons are. Now today we are going to learn about this first category of hydrocarbons, that is alkanes. All right. Right. So then let's start discussing about alkanes. Right. Right. So I have shared you the tute today. The tute is regarding these hydrocarbons. Right. The name of the tute is two hydrocarbons and halohydrocarbons here. So under the hydrocarbons and halohydrocarbons, we are going to learn only the hydrocarbon parts, and out of the hydrocarbons, we are going to learn alkanes today. Right. So without wasting further time, let's quickly move on to the discussion about alkanes. Right. So if we go to the note that I have given to you, right, it says alkanes are a group of hydrocarbons having only single bonds between carbon atoms. Okay, I explained that earlier. Right. So there are only single bonds between carbon atoms. Therefore, they are called saturated hydrocarbons. We call them saturated hydrocarbons. You can underline or highlight the word saturated. Okay. Then they have a common formula of CnH2n plus 2. Right. So we call this the general formula of hydrocarbons. Right. We call it the general formula of hydrocarbons. Each, not hydrocarbons, alkanes. Each alkane satisfies this general formula. For example, the simplest alkane we know is methane. Methane, we know the formula of methane, that is CH4. Right. Then second one, let's consider ethane, two carbon alkane. That is C2H6. Likewise. So in CH4, now we have one carbon. One. So then according to this general formula, CnH2n plus 2. So 2 times n is 2 times 1 plus 2. So it is 1 carbon and 2 times 1 is 2 plus 2, 4. CH4. Now it satisfies. Right. So it satisfies uh, the general formula, that is CnH2n plus 2. Right. Then the other one is ethane, 2 carbon alkane. So if it is 2, C2H 2 times 2 plus 2. See, 2 times 2 is 4 plus 2, 6. So it is C2H6. See, it's correct. So likewise for the alkanes, okay, now we are learning alkanes, right? For the alkanes, we have the general formula, that is CnH2n plus 2. Right. I think you got a rough idea about this common formula of alkanes. That is CnH2n plus 2. Right. Then let's move on to the next subtopic, that is the preparation of alkanes. Right. So we'll be learning about the preparation of alkanes. Now, there are several preparation methods of alkanes. Under that, the first one is hydrogenation of alkenes and alkynes. Right. So we call it the hydrogenation of alkenes and alkynes. So as symbolized, as it is expressed by the name, we call it hydrogenation. Hydrogenation means addition of hydrogen. Right. So addition of hydrogen is called the hydrogenation. Right. So let's see how that is done. Okay. Let's see how the hydrogenation can be done. So hydrogenation can be done by the reactant. As the reagents, we use so as the reagents, we can use uh, hydrogen gas with nickel catalyst. Right. Usually we don't use just nickel, we use rainy nickel. I'll explain it later. Right. Then we can use hydrogen with palladium, the catalyst, and hydrogen with platinum. Okay, so those are the reagents. So we, as the reagents, we can use hydrogen nickel, hydrogen palladium, and hydrogen platinum. Right. So I told you this nickel, we call it rainy nickel. Right. So let's see how this rainy nickel is being produced. So the rainy nickel is produced. That means the nature of the rainy nickel is they are like granules. They are small granules. Right. So usually we are melting the nickel metal, and then we are pouring it to a large water craft. Then nickel, the molten nickel will get solidified quickly, making small solid granules of nickel. Right. We call them rainy nickel. We do it in order to increase the surface area of nickel. Right. So once the surface area is increased, the catalytic activity of nickel will be increased as well. Right. So uh, these are the reagents that we can use for the hydrogenation of alkenes and alkynes both. Right. So let's see how this reaction takes place. Now we know that in alkenes and alkynes there are double bonds and triple bonds. Right. There are double bonds and triple bonds. Right. So ones with the double bonds are called alkenes. The ones with the triple bonds are called alkynes, right? And we know that once there's a double bond or triple bond, only one bond is sigma, and the other bonds are called pi bonds, right? Only one type of bond is sigma, the other ones are called pi bonds. Now, once these hydrogenation reagents are being added, the pi bonds are being broken and hydrogen atoms are being attached over the pi bond, right? The pi bond is broken and two hydrogen atoms will come and attach to the adjacent carbon atoms over the pi bond. Right, so let's see how that reaction will be taken. Right, first of all, let's consider nickel. I'm sorry, first of all, let's consider alkenes. If we consider an alkene, okay, now let's move to the note first. In the note, it is said that the pi bonds of alkenes and alkynes are broken and hydrogen atoms are added. Nickel, palladium, and platinum are used as the catalysts. The nickel we use here is called rainy nickel. The hydrogen atoms are absorbed onto the surface of the catalyst and they react with any unsaturation percent. Right? So they are going to react with any unsaturation percent. So let's see how that takes place. Okay, so let's consider this alkene. So that alkene, if we add H2 with platinum or palladium or nickel, anything, the double bond is broken and two hydrogens are attached to the carbon atom like this. Okay. Now you can see here we have the alkene. The alkene is converted in alkane. So this one is the reagent. Right. Similarly, if we consider an alkyne, that if we add the hydrogenation mixture H2 with platinum, both of the pi bonds are broken and hydrogens are being attached like this. So it is an alkane. Okay. It satisfies the general formula that is CnH2n plus 2. Right. It satisfies CnH2n plus 2. Right. So those are the reactions that we can write. So you can write down these reactions. You can write down these two reactions in the space provided in the tube. Right. Then next point, deuterium is an isotope of hydrogen. Therefore, if D2 is added instead of hydrogen, deuterium atoms will be added. So instead of H2, if we use D2, D2 will be added. It's like this. Right. Instead of this H2, if we have used D, say instead of these hydrogen atoms, D will be coming and attached. Like this, if we add D2. Right. So there's no much difference instead of hydrogen. Now we know that deuterium is an isotope of hydrogen. Therefore, D will be attached over hydrogen like that. Right. So you can write these two reactions in the space provided in the tube. Next. Right. So that is the hydrogenation of alkenes and alkynes. So that is the first preparation methods of alkanes. Right. So then let's move on to the second type of reaction. The second reaction is called the Clemenson's reduction. Second type of the preparation method is called the Clemenson's reduction. Actually, this is a special type of reduction that can be seen for carbonyl groups, right? So it's a special kind of reaction that can be seen for the carbonyl ones. So that means the Clemenson's reduction can be done for aldehydes and ketones, right? So this can be done for aldehydes and ketones. So as a reagent, we are using zinc amalgam with concentrated sulfuric acid, concentrated hydrochloric acid. Right? So this is the reagent. Zinc amalgam is an alloy of zinc and mercury. So we are using it with concentrated hydrochloric acid. So once the zinc amalgam with concentrated hydrochloric acid, that means the Clemenson's reduction reagent is added. There's a reaction taken place. So during that reaction, hydrogens are going to be attached to the carbon atom where the carbonyl group is present. Right. So to the carbonyl group, hydrogen atoms are going to be attached. So let's see how that reaction will take place. Right. So let's write some examples. Right. So before writing the example, let's go to the note. This is a special kind of reduction reaction shown only by carbonyl compounds. The oxygen atom of the carbonyl group is replaced with hydrogen atoms during the reduction. Right. So these are the examples. This if we are adding zinc amalgam with concentrated HCl, it will produce the alkane like this. Right. The oxygen atom is being removed. That is for an aldehyde. Now this is an aldehyde. Right. We call this aldehyde because it contains this COH group. Right. We learned it in the first session of the organic chemistry class. Right. Then the other one is ketone. To the ketone also, if we add zinc amalgam with complex Cl, it will produce this. So we have a ketone over here. So we call this ketone because the carbonyl group is attached to two alkyl groups from either side. So this is the reaction. Right. So you can complete your tute with these two reactions. I'll be sending you the tutorials, and for the online students, I'll be sending you the tutorials, and the physical students, you will get a tutorial, the second tutorial regarding this before the next class. Right. So these are the reactions that we can give for the Clemenson's reduction. Is it clear? Is it clear for you? Can't you hear me, Putal? Students, can't you hear me? All right, you can speak. Huh? Right. Right. Okay. So then let's move on to the next type of reaction. Right. We can learn the next type of reaction. That is by the Grignard reagent. Right. By the Grignard reagent, when reacting the halohydrocarbon, let's go to the note. When reacting the halohydrocarbon or alkyl halide with magnesium in dry ether medium, the magnesium atom is combined to the carbon and halogen. it produces the alkyl magnesium halide and it is known as the Grignard reagent. The alkyl magnesium halide produced is known as the Grignard reagent. Okay, let's see how this reaction takes place. Right, so let's move to the notes. So let's see how the Grignard reagent is being produced first. Right. The method of preparation of the Grignard reagent. Now there are several types of Grignard reagents in the organic chemistry, but all of them have a common feature, that is they are alkyl magnesium halides. Right? That means there's an alkyl group, magnesium, and a halogen. For example, H3 MgCl or MgBr. Alkyl magnesium halide. Then there can be a benzene group, MgBr or MgCl, likewise. So any alkyl group. So these are all Grignard reagents. Right. So those are the Grignard reagents that you need to know. Right. Actually, right, there are different types of Grignard reagents. Now these are some common Grignard reagents that you can find. All right. So let's see how this Grignard reagent is being produced. So in the space provided, you can write how this Grignard is being produced. Once there's an alkyl halide like this, CH3Cl, and it can be reacted with magnesium in dry ether media. So it will produce CH3MgCl. Right? So it can produce CH3MgCl. Right? So this is alkyl halide and this is called the Grignard. Right? So it has to be specifically dry ether. Usually an ether is a compound like this. There are two alkyl groups attached to oxygen atom. So dry ether, that means this ether is a solvent, right? Ether is a good solvent, right? We use dry ether because dry means we do not use water, right? It's a waterless ether medium. Because if there is water, water will quickly combine with this Grignard and it will produce an alkane. Okay, that is the reaction that we are going to use to produce alkanes, right? To produce stable Grignard reagent, we do not need an aqueous medium or any wet medium. Therefore, it has to be essentially dry. That's why we are using a dry ether medium. Okay. Then let's see this one. Let's move on. Right. So that is one way of producing grenade. Let's consider an aryl group. Aryl means a cyclic group. To this, if we add magnesium with dry ether, it will produce this. Right. So both are grenades. Right. So in the space provided in the first space provided in the second page, you can write this. Okay. Then the next point, when the grenade reagent is treated with any species which can donate H plus ions, it is decomposed to produce alkanes. Right. So then the grenade will be decomposed and it will produce alkane. Right. So let's see how this takes place. Let's say we have a grenade like CH3, CH2, MgBr. Right. To this, if we are adding a dilute acid, for example, let's say we are adding dilute HCl, then there are H plus ions in the medium. So this MgBr will combine with Cl and it will be removed, and H will combine with the alkyl part. So it will produce the alkane CH3, CH3. Then MgBrCl will be removed. MgBrCl will be removed and it is given off. So this will produce the alkane. This is the main product, alkane, and the byproduct is MgBr3. Then I can give you another example. Right, to this one, if we add any species which can give H plus ions, for example, even with water, if you produce this with MgClOH will be given off. Okay, we don't need these parts. Right, only the organic products are required. Right, we have to consider only the organic products. Right, so this is how they react with grenade. Right. So conversions means in this organic chemistry we have to do conversions. In a conversion, we can combine these reactions together and we can write it as one-step reaction. Okay, let's say if you are given an alkyl halide, like this. Then to this, as the first step, we can add magnesium with dry ether. So we learned that once we add magnesium with dry ether, it will produce the grenade. Then as a second step, we can add some water. Right. So if we add some water, that grenade will be converted into an alkane. So it will give CH3 as the product. So in a conversion, in organic chemistry conversions, we can use these two reactions together and combine together and use as one step. Okay, that is another usage. Right. So then let's move on. So these are the three preparation methods of alkanes that we need to learn. Right. Then the next one is reactions of alkanes. Excuse me. Right. So if you are considering the reactions of alkanes, we can say that the alkanes are very inactive organic compounds, and due to its inactivity, alkanes do not react with very active metals like sodium or potassium. Right. So they, due to the inactivity of alkanes, usually they do not react with sodium or potassium. That's why in order to store sodium and potassium, the highly reactive metals like sodium and potassium, we can use wax like paraffin. Paraffin is an hydrocarbon. It's an alkane, right? So due to its inertness, we can use it to store sodium and potassium. We know that sodium and potassium, they are highly reactive with water, and they are causing vigorous reactions. Therefore, we can use alkanes for the storage purpose. Right? Then, so do not react with active metals like sodium and potassium. But alkanes react with halogens due to the higher reactivity of halogens. Now, halogens are highly reactive, especially chlorine, right? So therefore, excuse me. Therefore, due to the higher reactivity of halogens, they can combine with alkanes, and they can produce alkyl halides. So as the product, they can give alkyl halides. Right. Here the halogen atoms are substituted into the traces of hydrogen, therefore it will give alkyl halide. The reaction of alkanes with chlorine is explosive. Right. Fluorines are highly reactive, the reactions are explosive. Right. The reactions of alkanes with chlorine does not take place in the dark. It will take place in the presence of diffuse sunlight. So it will take place in the presence of diffuse sunlight. So reaction of bromine with alkanes is very slow, even in the presence of sunlight and catalyst. Okay. Reaction of bromine with alkanes is very slow, even in the presence of sunlight and catalyst. So the reaction I will give you with the help of methane. CH4 in the presence of chlorine gas with H nu means the energy of a photon. So the chlorines will replace the hydrogen atoms and it will form CCl4, carbon tetrachloride. Okay. Then we can say the energy given by diffuse sunlight is required to break the CCl bond. So it will produce two chlorine free radicals. Okay, so let's see how these chlorine free radicals are formed. Now we have the chlorine atom, chlorine molecule. There are two chlorine atoms in the chlorine molecule. Once we supply energy using an energy photon, H nu, this bond undergoes homolytic fission like this. That means the bond is broken equally towards each other. As a result, each chlorine atom will get an electron, so it will produce two chlorine free radicals. We call them free radicals because there will be an unbonded electron on the top of the atom like that. So it will form two free radicals. Right. So this is this is the only reaction that is shown by alkanes, right? That is the chlorination of alkanes. So there's a mechanism for this reaction. Now we are going to learn that reaction mechanism for the chlorination of alkanes, right? Now this mechanism, it takes place in three steps. Chlorination mechanism. So as I told you, this takes place under three steps. Let's learn those three steps. First one is the chain initiation. The first step is that is chain initiation. Right. So let's see how this initiation takes place. Okay, the three main steps are the initiation, propagation, and termination. Now we are going to learn the initiation part under this. Right. So chlorine molecules undergo homolytic fission in the presence of diffuse sunlight and forms chlorine free radicals. Okay. Chlorine free radicals attack the hydrogen atoms of the alkane and form a new type of free radical. So let's see how this takes place. Two chlorine atoms in the presence of diffuse sunlight. This will undergo homolytic fission like this. So it will produce two chlorine free radicals like this. Then we have CH4 molecules. Okay, we have this CH bond. It is being reacted with, it is being attacked by, thus form chlorine free radical. So this bond will undergo homolytic fission like this, and it will produce the H3 free radical and releases HCl. Okay. It will release HCl molecules. So this is the chain initiation step. So in the initiation, it will produce a free radical of CH3. Then the second one is the chain propagation. So step number 2, that is chain propagation. Chain propagation. So there, the CH3 free radical formed will react with another chlorine molecule and forms CH3Cl. It will react with another chlorine radical and forms CH3Cl. Right. Then and the chlorine free radical. Then thus formed chlorine free radical reacts with the CH3Cl and it will remove another HCl molecule. So it will produce CH2Cl free radical. Likewise, the reaction will go so forth until CCl4 is formed. So there are several steps for the chain propagation. Right. So let's see. So here we have the CH3 molecule and two chlorine atoms. We combine like this to produce CH3Cl and chlorine free radical. Right, CH3Cl and chlorine free radical. Then we have this produce CH3Cl. Right. So it will react with the form chlorine free radical and it will go forward like this. So it will produce CH2Cl free radical with HC. Then that forms CH2Cl free radical again react with chlorine. It will be broken like this to produce CH2Cl2 and a chlorine free radical. So this will react again with chlorine free radical. So it will form CHCl2 free radical with HCl. Then CHCl2 free radical will react with another chlorine molecule like this. Then it will produce CHCl3 with chlorine free radical. Then again reacts with the free radical and produces TCl3 free radical with HCl. Then CCl3 free radical will combine with another chlorine molecule, undergo homolytic fission like this, and it will produce CCl4 with chlorine free radical like this. So this is the chain propagation. I think you can understand this. Okay. The chain propagation takes place in this manner. These are the reactions. Right. So after the chain propagation, it will come to the termination. Right. So it has produced CCl4, and then the reaction comes to the end, that is called the chain termination. The formed free radicals will break the existing molecules, and the reaction will proceed until all the reactants are over. So if the free radicals in the reaction mixture are removed, thus the reaction will terminate. So let's see how that takes place. Okay. The reaction will terminate here. Step number 5. The formed free radicals can react with another chlorine free radical. So it will produce Cl2. So if the broken Cl2 bond is formed again, the reaction will terminate. The reaction will stop. Then there are CH3 free radical forms. They can combine with another CH3 free radical at the start and form CH3 alkane. Then the reaction will stop over here. Again, CH3 free radical can be combined with another chlorine free radical. So it will end up with CH3Cl. So that is also the termination step. Right. I think it's clear for you. Right. So those are the chain termination steps. Right. So if you move to the next point, since the mechanism runs through free radicals and hydrogen atoms are replaced with chlorine free radicals, the mechanism is called free radical substitution. So this mechanism is called the free radical substitution. If the chlorination of methane is done using excess chlorine, we can obtain CCl4. Right. So let's see how this reaction takes place. CH4 is reacted with excess chlorine and HNO. If you are using excess chlorine and HNO, right, then the reaction will take place and the final result will be CCl4. We will end up with CCl4. If we use excess CH4 instead of excess chlorine, then the product will be CH3Cl. If we use excess CH4 with chlorine HMU, then the product will be CH3Cl, not CCl4. Right. So here we have used excess amount of chlorine. Here we have used limited amount of chlorine. Right. If we use limited amount of chlorine, the reaction will end up with CH3Cl like this. If we use excess chlorine, it is like this. So that means if the chlorination of methane is done using excess chlorine, we can obtain CCl4. You can write this over there. Then if we use limited amount of chlorine, the reaction will end up with CH3Cl. So this is the reaction. Then the stability of the free radicals will be increased with the increasing steric hindrance. Right. So the stability of this will be increased with the increasing of the steric hindrance. That means the addition of alkyl groups. If there are more alkyl groups joined, then the stability will be increased because the reactivity will be decreased with the added alkyl groups around the carbon atom. So the steric hindrance will be changing like this. See, around this carbon atom with the unpaired electron, we have only two hydrogen atoms and one alkyl group. If we consider another one, See, around this one we have two alkyl groups and one hydrogen. Then in the other case, there are three alkyl groups. Therefore, the steric hindrance will be increased. So here, in this direction, the steric hindrance increases. That means the stability increases and the reactivity decreases. So those are the properties that we can compare. Right. So that's all regarding alkanes that we have to learn. If we consider the properties of alkanes, now let's discuss the properties of alkanes as well. Okay. Alkanes are non-polar organic molecules, right? Alkanes are non-polar organic compounds, uh, and there will be very weak intermolecular forces. We call them London dispersion forces between the two molecules. Therefore, they have very small melting and boiling points. Usually, alkanes have very small melting and boiling points, and as a result, one carbon to four carbon alkanes are gases at room temperature. Then carbon 5 to carbon 18 are liquids, and carbon 18 above are solids. So because of their low melting points and boiling points. Right. So therefore they have very small melting and boiling points. Second property, when the molar mass increases, the intermolecular forces will become stronger and the melting and boiling points are increased. And the melting and boiling points are increased. Also, the surface area of the molecules increases, which will increase the dispersion forces. Okay. This leads to a aforesaid variation in the physical states of hydrocarbons. Right. So we can write this thing that I have written in red color over there. So the variation of the physical state takes place due to this. That means carbon 1 to 4 are gases, above that means in between carbon 5 and 18 are liquids, and above carbon 18 they are solids. Is it clear? Right. Since alkanes do not form bonds with water, the alkanes are water soluble. Sorry, alkanes are water insoluble. Since alkanes do not form bonds with water, they are water insoluble. So that is a property of alkanes. Right. So those are the main properties of alkanes that you need to know. There's another thing you need to know that I haven't given in the queue. Right. Once the molar mass of alkanes increases, right, that means once the numbers of carbon and hydrogen atoms increases, their melting points and boiling points will increase because of the increased molar mass. Right. So that is another property, and that's all regarding alkanes. Right. Based on these things that we have learned today, now let's start discussing conversion. Now I told you that we need to discuss conversions regarding these hydrocarbons. Not only hydrocarbons, regarding organic compounds. Now let's go to a conversion. And I'll do the first one for you. So this is the conversion that we need to do. Now, organic conversions means you are given a reactant and you are given the product. So you have to convert that reactant into this product. So let's see how this is done. Right. Now, there's no any single reaction to convert this into this. If there's a single reaction, it is the best. And therefore, since there are no single reactions for this, we can use the simplest possible route to convert this into this. Right. So as the first step, what I'm going to do here is I'm going to remove this oxygen from here. So once we remove the oxygen, we will have the carbon-carbon double bond, and this will become CH3. For that, we need to add the Clemenson's reduction reagent. So I'll be adding zinc mercury with concentrated HCl to convert this into this. Then I'm going to remove this double bond. For that, I'm going to add H2 with platinum. Right. So once we add H2 platinum, what will happen? The pi bond is broken and two hydrogens are going to be attached. Now, for this purpose, we learned those reactions of alkanes and alkenes. Sorry, reactions of alkanes and the preparation methods of alkanes. Right. So for this, I think this is clear for you. There's no space given in the tube for these conversions, so you have to write this in your notebook. Okay, in your notebook, you can do the conversion. So with the help of this one, I'll be giving you the second one as well. You can try the second one. I'll give you a couple of minutes to try the second one. Okay, for now, you can copy down this first one. Copy down the first one and try the second one quickly. I think the time is enough. So let's discuss. Right now, the most important thing in doing the organic conversions is you have to check whether the number of carbons have been changed in the reactants and products. Right. So in the reactants, here we have 1, 2, 3, 4 carbons. In the products also we have 1, 2, 3, 4 carbons. So that means the numbers of carbons have not been changed. Okay, so that's a good thing. Because if the numbers of carbon has been changed, then we have to add or subtract the carbon atoms from the original atom, original molecule. Right. So therefore, we don't need to change the numbers of carbons. Here we have a double carbon bond. So we can remove this pi bond by adding a hydrogenation reaction. Then we have a halogen over here. The halogens can be removed by converting into a Grignard and then removing the Grignard. Right. So those are the things that we can do to this molecule. Okay. So let's see. First of all, we can add H2 platinum to this one. Then we can add H2 platinum. Then the pi bond is being destroyed. Okay, like this. Then for this one, we can add magnesium dry ether as the first step. As a second step, we can add water. It's better if we can acidify water with a dilute acid like this, H plus H2 water. Right. So that's how we do that conversion. Right. Okay, now Ashmita, the answer that you have sent, only one part is correct. I think you understood it now. Right. So I'll give the third conversion as well. Now don't get upset because now this is the first time that we are doing a conversion. Right. So at the end of this organic chemistry course, we will be doing about 200 plus conversions. So you will get a good practice at the end of the lesson. Right. Third one. This one. Try quickly. I'll give you 5 minutes. Actually, 5 minutes is more than enough. But since this is your first time to doing conversions, I'll give you some more time. So quickly try this one. Okay, I think the time is enough. Let's see how this is done. Huh? Right. So here we have two carbons. This group has to be converted into CH3 and this also has to be converted into CH3. Now this is an aldehyde group, so we can do a Clemenson's reduction. Right. Right. So we can do the Clemenson's reduction to reduce this one. And here we can use Grignard reagent. Okay. So if we add Clemenson's reduction, CHO group will become CH3. And the CH2Br will be converted into CH3 by adding Grignard. First step we can add magnesium with dry ether. As a second step we can add acidic water, H plus H2 water. Right. Okay, so you can do this like this. Right. So that's a conversion of alkanes, right? Those are the conversions regarding to alkanes. Now, now we have done a small part of the organic chemistry lesson that is regarding alkanes. What are the properties of alkanes and how we are going to prepare alkanes and what are the reactions of alkanes. Under that, we learned there are three preparation methods of alkanes, that is hydrogenation, Clemenson's reduction, and with the help of Grignard reagent. And then under the reactions, we learned the chlorination mechanism of alkanes, that is a reaction. And we need three conversions like this. As I have promised you, at the end of this organic chemistry course, we will be doing more than 200 conversions, and then you will be an expert in organic chemistry. Now, I must say this at the end of the lesson. Whenever we are learning organic chemistry, you will find it as easy, right? Because I know personally, because this organic chemistry is one of the easiest part in the syllabus. But the thing is, whenever you are not engaged in organic chemistry, the theories will get erased from your mind quickly, right? That means whenever you are engaging in the work, it will be revised. That means your knowledge, your memory will be refreshed day by day. But whenever you keep organic chemistry aside and do some other work, then all the things will be wiped off from your knowledge, from your memory. So don't be like that. Always you have to be keep in touch with organic chemistry until your exam, right? So then you can get a good score regarding this organic chemistry, because there will be about 12 MCQs in the paper out of 50 and 250 marks out of the 1000 in the second paper, right? That means as approximately this organic chemistry carries about 25% marks in your final exam paper. So therefore, this is one of the most important things in the organic chemistry, is the organic chemistry. Right. So with that thing, that was the part that I was going to discuss today, that is regarding alkanes. So this is the end of alkanes. And in another session, we will be discussing about alkenes and alkynes. Right. In addition to that, there are some other introduction parts of the organic chemistry. We will be covering those parts in the upcoming lessons. Right. So keep in touch with us. And that's all for today. And okay, I'll be uploading this video to the YouTube, and you can subscribe my channel, and then you will be getting updated about the future lessons that we are discussing in this class. Okay, then this is the end of the class. Good night, everyone.
Thank you and God bless you, sir.